So this is a molarity question here, and we're being asked to determine that molarity. And the formula for molarity is as follows. It's going to be molarity equals, especially we're looking for the molarity of X here, because that's what it says in the problem. So it's going to be moles of X, which is the solute, divided by the liters of solution. Now that's important for its solution, which is really going to be the combination of X and Y. So let's take a look at how we're going to find the moles of X. So the moles of X is going to be the mass of X times 1 mole over the molecular weight of X. And we're given all of these things, and it's going to be 35.00 grams. Now keep in mind, if you're given a volume, you'd have to convert that to the mass by using the density. And there's an example of that in the previous problem, in the percentage problem. And the molecular weight we're given is 63.00 grams of X. This is going to come out to be 0.5556 moles of X. So that's 4 sig figs. Now we need to figure out the volume of the solution. The volume of Y we're going to have to get from the density, because it's going to be the mass divided by the density. So the mass of Y divided by the density of Y. And the mass of Y is 895.00 grams. The density is given as 1.171 grams per mil, which comes out to be 764.3 mils. The volume of X is 0 mils, because X is a solid. Now keep in mind, if X wasn't a solid, you would have to actually account for this volume in the solution, because the solution is going to be the volume of X plus the volume of Y. In this case, X is a solid, so we don't have to be concerned about that. The volume of the solution now then is going to be the volume of X plus the volume of Y. And we're going to find this in liters. So let me add that down in here in liters. So that's going to be times 1 liter over 1,000 mils. Now that's going to come out to be 0 mils plus 764.3 mils times 1 liter over 1,000 mils, which is going to be 0.7643 liters. Now to get the molarity, we'll plug in the moles of X that we found, 0.5556 moles of X, divided by 0.7643 liters, which is going to come out to be 0.7366, and the unit there is big M, or if you want, moles per liter, which is going to be the same thing. Now keep in mind that the volume of X is not always going to be 0. It is in this case because it's a solid, but if X is a liquid, then this needs to be accounted for here as well.